Welcome to the GridMod Pod, brought to you by AEIC. In this podcast, you'll hear from the utility industry's top operations leaders on how their companies are working to modernize and improve our ever-evolving power grid. Thanks for joining us.
Welcome to the GridMod Pod. I am so excited to have you too. I will say this is our first podcast episode where we had two guests at once, so here I go being challenged. And also, we're going to talk about, I actually say a lot of my topics are the favorite, but this one was kind of the beginning of understanding how distribution grids could be seen as something of an asset if the edge could behave or we could think of it differently to really offset or change the way we think about energy. So dare I say we're going to talk a little bit about thermal energy. Anyway, so I came into seeing you guys at a conference, shocker, about data centers and the amount of energy. And so you guys are from SmithGroup, and I know you started a new group, a new team that I would love to hear more about. And then we can kind of get into our conversations about how, with all of this new increased need of energy, what are we thinking about at the edge, which is somewhat of a novel idea because, the industry has been siloed, and now we have to really think of the generation, the transmission, the distribution, the edge as a full part of the power grid, and each one has, I think, a potential to be a part of the bigger solution. So with that, I'll let one of you go. How about Stet, since you said hello first?
I'll jump in because we are really excited. So exactly to your point, I feel like historically, we each have had our specialties. Somebody focused in grid distribution, somebody focused on rate programs, somebody focused on building engineering, and we haven't had a lot of chance to interact, not just actively through grid programs, but just through navigating what could be a really potential change in how we approach buildings and grid and that edge condition. That whole thing was kind of part of the impetus for us to launch a new team at SmithGroup. So we have a team called Impact, which is our intentionally multidisciplinary performance and climate action team. With the idea,
acronyms, we're known for them too.
Yeah. Well, the idea is that we have to break the silos if we're going to make meaningful change around climate action and make climate action actually actionable. And so we've brought together sustainability services, engineering, architects, planners, resilience planning, and economics all into one team, which is, I would say, probably fairly unique in the industry. But that gave us the chance to launch the Climate Advisory Board that you got to attend, which is really exciting of looking at this intersection between science and technology, AI, data centers, but also the infrastructure that supports them and how we're kind of missing a chunk of how that infrastructure could actually have a community benefit. And so we're pretty excited to be here to talk about that intersection. And my colleague, Katrina, kind of holds...
She is a previous guest.
Yes.
And we did share, grid edge, smart electric energy districts. And so now I think we're just going to go a shovel deeper or two. But go ahead, Katrina, introduce yourself.
I was going to try and do a riff on that, like first time caller, long time friend, but then I was like, wait, it's actually the opposite, but whatever. But doing that, but it's really exciting, I think, to be here because the context of what you're talking about, what we worked on a few years ago was also an example of just how quickly this stuff is changing. When I came 2 years ago, a year ago, we had just started collaborating really what the concept of a smart all electric district looks like. Obviously, Stet is my partner in crime in so many ways, and him speaking more, thermal grid world. I do that in unison because, as I say, all of us speak both kilowatt hours and kBTUs, which if people don't know what kBTUs, like, it's mind blowing, but also really annoying to complicate and kind of do those load sharing curves together. It's the worst. But we had just started collaborating. We were like, we can translate all this amazing work he'd been doing in California on kind of electrified buildings and talking about what on scale Pittsburgh. We kind of had landed on, the concept of, we can totally electrify buildings, cold climate, heat pumps do work. Like, we kind of busted that myth, I think, which I'm really proud of. But I think today, to your point, we're taking it a step further, double shovel down, whatever you just called that in a fun way. But we are really going beyond now just thinking about what district energy looks in a very American way. I say that it's not in the same kind of, centralized context that a lot of our hopefully Danish friends that are listening might be accustomed to, but we are really, really proud, I think, of more of the climate resilient types of infrastructures that our teams work on. A lot of those tend to be kind of, heat pump based systems, even ground source heating systems. So taking that into kind of our science and technology practice and saying, hey, you guys are building mission critical assets that are huge heat dumpers, also huge electricity users. It was fortuitous. And I know that's what we're going to talk about today. You were just, Liz, coming from the grid conference where you were having the other side, like, oh my God, there's so much data centers that are coming online. It's going to increase our electrical load so much. The planning's not there. So I'm excited because 2 years ago, we were just stuck on like, this is how you do kind of bidirectional metering. And then 2 years later, we're like, bidirectional metering sorted, geo exchange sorted. Now, what's the data center do as part of district energy systems with heat pumps? So, and like, it's been 2 years. So cool.
And so for any new listeners, I'm going to just ground us a little bit. So the grid the grid modernization. So it's a term that's being used in our industry of how are we taking a grid that's built over the last 140 years and retrofit, rebuild, and really think through the redesign of a very large machine as all of these new technologies become available to the individual consumer customer. So that's big in itself. And so I'm going to kind of tee up after my little grounding episode with a direct question just to kind of make sure, our listeners are following. And as Katrina just said, this space is moving very rapidly. And I think the whole reason I started the podcast was really to give a voice to the electric utility folk to understand all of the varying perspectives that are occurring across our nation, in particular based on mandates or goals that are being constructed on the behalf of themselves, and then they have to return and perform. And then there's also utilities that are not facing those goals, but also starting to realize the technology, the data, and the systems that are available can actually be utilized to baseline our current performance as grid owners and operators to achieve success as we know today, as well as setting us up for that future. So in a nutshell, we're going from a very centralized bulk electric system transmission distribution to the edge to this thought process of what does this system look like when we start to decentralize the infrastructure. So, and while doing that in the face, we did mention data centers, and I'll just say those came up in the last, not to date the episode, in the last 6 to 9 months. It went from a topic that was under, let's say, percolating to now we are seeing enormous requests of the transmission grid to deliver. So what a great space to be in of how can we look to the distribution grid to take some decentralized ownership and start utilizing the edge as an asset. So in the face of climate change, really, which the only thing we have against us is time. I feel like that was a movie quote that I just watched last night. But anyway. So how does, and I'll just start up to, you guys, the designing, this is simple. So I'm throwing in easy buildings and infrastructure with climate at the center make really the building itself more resilient as well as the grid.
That sounded like a simple question. Just want to say that was a loaded question. Stet, do you want to go first?
Yeah, well, I would say that it can. I would premise it with it can, but
now,
it
remember,
doesn't always.
You can be the teacher and take us into it.
Yeah, because I think this is really important. I think as we look, especially in the market right now, where a lot of local ordinances are driving rapid retrofits of buildings for all electric design, kind of like, gas pedal down, so to speak, not to use a fossil fuel reference, but kind of go, 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 go. No thinking, just go. One of the things that isn't happening, but that could, is that buildings actually can play a role in building in both resilience from an operational standpoint for the building itself, but also put less strain and stress on the distribution system. But there's not a lot of, hey, if I do this for my building, if I design this in a certain way, and it provides a grid benefit, there's not a lot of conversations going back and forth, whether it's a program or communications of even what the desire is from the grid to the building owner. It's kind of like, building owner, do what you want. The grid has to respond. Like, that's kind of like the relationship. And I think that puts a lot of risk on the table for all of us. And so some of the things that I would just throw out as examples is a more resilient all-electric building that's like heat pump based, for instance, has heat pumps for space heating, cooling. Those systems can be more resilient if you add thermal storage to them, which is thermal storage is something that nobody ever talks about on the grid scale very often. Sorry. Ready,
Well,
Sam?
I just want to ask a question because I don't know these things.
Yeah.
When we talk about heat pumps, there's air source and ground source.
Oh, yeah.
And so is that
Or
what
water
we're
source.
Water source. Yeah.
Okay, so is that what we're exploring when you're talking about, like, 2 years ago, Katrina, we were talking about, hey, these air source systems could be used to electrify, but now we're like shifting to that's a large amount of electric source. So is there ways that we could use other parts of our ecosystem to
First,
Yeah.
no, totally. First, that has to do a myth buster for you before you even finish that sentence. Myth busting time.
Okay,
Yeah.
great.
That
Yeah.
COP efficiency of heat pumps, which we coefficient of performance, compared to coefficient of performance for that boring old boiler.
Yeah.
Stet,
Easy.
take it away.
Easy. So a typical boiler, even the best in class boiler, might be rated at a 96% efficiency or 0.96 value of how much energy you put out versus what you actually get out at the input. Put a bunch of gas in, burn it. You're lucky if you're going to get 96% of that energy thermally for use. In real life, in measured practice, it's down into the 80s. So there's rated efficiency, but then real life, because of poor design, poor sizing, short cycling, all a bunch of things, actual performance is about 80% efficient, 85 if you're lucky. And so there's a bunch of field studies that have showed that. A heat pump is the electric version of that. And instead of burning something to make heat, we're pulling heat from the air, from a water source, from the ground, and we're moving that. So we're using energy just to move heat into our buildings from where it wasn't, or where it was before. We're moving it into our buildings or moving it out of our buildings. So it's more of a transporter than a creator, so to speak. The efficiency of those heat pump systems can range from, on a bad day, 200% efficiency to, on a good day, 900% efficiency if we're doing the thermal energy networks that we're talking about. So huge gains from an efficiency standpoint. And that has a big deal on its impact on the grid. Because if you think about trying to do the same amount of work, but with a fraction of the effort, that effort is what the grid has to support. And so we want to focus on efficiency for sure. So I love talking about coefficient of performance any day. But
and I mean, those are, one of the purposes of creating a podcast that's educational is really to help connect the dots to all of these very granular
in the
threads that play a huge part of the transformation, but are very technically challenging to communicate to the masses. So it's, how do you get our foothold in something and then changing it? And I'll just say, I've said this a couple of times the last couple of months. I think I said it when I was with you all in Chicago. There's 5 transformations happening: the energy industry, transportation, supply chain, food and agricultural, but how we communicate. So, taking something as profound as what you said and then making it matter to all of those that are designing and developing or thinking about retrofitting old buildings. That's information that's not, easily available or understood or can be achieved. So maybe that is what we'll kind of get into.
And let's talk about the paradigm that's not changing behind all of those that I think has kind of, and I think it's just recognizing it because there's been intentional, kind of divisions between our worlds. That's just how, whenever you look at back how electricity was created in, the original time periods, right? The power structures around that meant that originally it was the people making and distributing just electricity themselves were, handling that electricity side of things. But historically, heating has been something that's a thermal asset, and that's been a totally different type of company. Yeah. So whenever we look at today, like all those paradigms that are changing, unfortunately, the one thing that hasn't been changing too quickly are probably like the regulatory bodies themselves that kind of mandate or help incentivize some of those almost interdisciplinary, but also inter-industry dialogues, if you will. And so, and that's really tricky. I think at the basis of it, one example that we all have learned from working together, for instance, is that like urban environment, city master planning processes have hugely been about just development, where you're going to plunk buildings down, where you're going to do sort of massive zoning changes, if you will, land use specific. But what we've all found actually, and I think it's the larger scale of our work that we then try to zoom into, is that the utilities are always left out of that conversation. Historically, just mandate utilities to be reactive and not to be proactive partners in all of this. And it's really a testimony, I think, to a lot of the utility players that we've been engaging with, that, you represent. A lot of them want to be those proactive partners because, to your point, the grid is old at times, it is stressed, but there's tons of technology that's available. So everybody, I think that's the good news. Everybody wants to play in the sandbox together, but unfortunately, we're just all trying to figure out what that looks like in perhaps, language communications. So it's definitely challenging, but I think the intentionality between having those discussions between not to be facetious, but literally that's the best thing about heat pumps, right? Is you kind of make your thermal discussion still electric. And in buildings, that's a big shift. Now you're handling just, on building demand side, you just having to talk to one engineer, not two different types of engineers. So I think electrification, sometimes we don't give enough credit for how much easier it's making designers to kind of collaborate and facilitate that interaction with utilities themselves.
I would just say, that's really where you and I originally met, just thinking through the power of synergies and understanding of each other coming from the different spaces. As I was working for utility, I found that the last person to come to the table was the utility when asked to perform. And then the realization that it wasn't that, and this wasn't just the particular utility, all utilities, and you just said it, do not want to contribute or partake. But there's actual real defined reasons why they may not be able to jump or react. And it could come down to legislative law or a regulatory tariff or some rule that was made 40 or 50 years ago that is fundamentally outdated and wrong, right, or different. It was created at a time when it may have helped. But now in this space, that exponential space that we're in, that rigmarole is really kind of what's hindering some of those fluid, synergistic conversations. And I think the power of data and being able to model these systems and be able to gain some of the quants that you just shared, Stet, and put it on, on a platform to really be able to share effectively and do a rinse and repeat is something that we didn't have 3 years ago. So now we have the ability to run models, create the awareness, and then drive conversations that I think it may feel a little slow for us that's been in it for, 20 years or so, but that we're on that hockey curve of unlocking these conversations between each other.
And the irony is that we're talking, one of the things that we've been talking about is the stressor that AI and data centers have been placed as a demand on the grid. The flip side to that is exactly the types of analytics that you're talking about. And I can think of examples that are happening right now at Argonne National Lab, that are happening at Oak Ridge National Lab, NREL, where they're modeling full grid distribution balancing with a thermal component as an underlying engine that are letting us actually play these what-if scenarios for the first time at scale. Heavily computationally driven, very large modeling sets, very complex analytics, but they're kind of the key to unlocking, I think, that next gen conversation of stopping to look at, this is my bucket, this is your bucket, let's go walk our separate ways. And there's a lot of things that we're learning can be deployed that are actually mutually beneficial. The co-benefits across the disciplines is really the exciting space that's happening right now in this area.
Right, it's definitely catch-22 because these technological advancements are unlocking the capabilities for these decentralized systems, but at the same time, they're now drawing an enormous amount of energy. The systems in themselves that we've been working in are changing in different fragments, but we can study it and then we can actually come up with big solutions.
We've got some fun stats to support your big solutions, if you will, that'll help us kick off that conceptualization, because we need fun facts in our lives, right?
We like numbers.
The best thing that
let's hear them.
I mean, it's staggering a little bit. So I just want to, But we have a solution. So let me preface, we have a solution that we can talk about today. Is that since some of those examples, especially, we should get into the discussions about digital twins, which is doing chef's kiss for design, but also should be chef's kiss for you guys. Like, we'll do that after the stats. Data centers will use 8% of U.S. power by 2030, compared to 3% in 2022. That means for U.S. utilities alone, sorry, my handwriting is so embarrassing, but for U.S. utilities alone, they'll need to invest around $50 billion in new generation capacity just to support that generation demand curve for 2030 increase. So $50 billion in just generation alone to support that increase. Well,
in a 6-year band.
That's a lot.
That is, like, if we think about those types of load took 100 years to build.
Yeah.
Maybe 80.
And so that's like that grounding, and that was a lot of our discussion when we were all in Chicago together. That grounding is, if we take, and I'm not saying that we have to take that as inevitable, but if we take that as like, that is where we are shifting as a society to be even more data intensive, data driven, AI, solving all the things. Is there a way that we can take that massive percentage gain and offset other demands that are happening simultaneously in a way that can reduce the demand on the infrastructure? And so that's kind of where a lot of the discussions right now around thermal networks play a huge role, because my favorite quote about data centers is that it's effectively a toaster. And for a long time, we've been making toast and throwing it away. But we should really be locating there somewhere where we want to eat toast. And the idea of taking that waste heat from this toaster and using it to offset what might be another demand from a new heat pump, there's actually a way to think about these synergistically. And so rather than 1 + 1, what if 1 got rid of 1? Or 1 made 1 half as big? There are ways to start thinking about these full energy cycles, as long as the electrical engineers and the mechanical engineers actually start talking to each other and include planners at the table. Like, that is just the beautiful intersection.
Not to give more numbers, but to give more numbers, because it was like staggering for us. But we've been in meetings before with grid experts, and they're like, but we need storage, right? I can't fit a lithium-ion battery there. And we're like, we know you don't have to. You have a building. That's storage. Be excited about it. Yeah. But we looked at, like, what's the waste toast, if you will, for waste heat specifically for one of these data centers. We on one data center, and it's, not a gigantic one. I'd say it's standard mill for us, if you will. I'm not going to give accurate numbers because let's respect people because you don't have those things. We're going to say it's around 100 megawatts worth of power to move. But export of this in this one building, if you will, whenever we quantified the waste heat that they weren't going to do anything with, it's enough to heat, it's enough to heat almost 14,000 residential homes, or around, 2 million square feet of commercial space. So whenever you ask
in a cold climate.
So whenever people are saying right now, too, speaking of, we have now data centers all coming online, we have increased power needs by 2030. Oh, by the way, electrification for homes is also changing. Electrification of buildings is also changing. What's the solution to this? We're like, well, you have a bunch of waste heat actually coming off of all of these data things. Like, we could solve one of these problems if we can capture that waste heat and put it into thermal districts. It's like the most beautiful coupling to building electrification that one could imagine. It's just, it doesn't seem to be happening too often because we're missing the question, who's the guy that builds those things?
And that goes right back to your regulatory question, or the historical framework of the role of the utility.
And just thinking from the utilities hat, which, this episode will come after an episode that was released where there are very large utilities that are looking at the distribution demand and customer-driven programs to offset usage. They're looking for those bag of solutions so that they can offset their overall transmission and generation build-out. So it's like, these are real solutions that the industry is actually looking for. So put the utility hat on, you find out, oh, there's this phenomena where we can use buildings as an asset. Well, now, let's say the utility drives the project. How do you create that partnership? How do you create the awareness that that need exists in these pockets of the grid, and then have the building developers and the designers and those that want to be the change show up? So that in itself is a problem, but doesn't mean there's a solution, because the only way to get the information out there is to share it. So what you're saying is, you guys have been actively designing and building these systems at the edge to offset the proposed electrified heating growth, but now offsetting that with using these thermal systems that are more efficient.
Yeah.
Right?
And the 100%, like the thermal systems with the waste heat are just, to quote Katrina, chef's kiss. Like, it's just like so beautiful. It's such a beautiful goal. But the challenge is traditional electrical utilities they don't have the 100-year plus history of playing in the thermal space, of running thermal networks with pipes, with water, glycol, they're like, that's not our specialty. We don't even have engineers in-house that do that. Meanwhile, the gas industry, who's quickly seeing their markets shift very quickly in front of their eyes through a declining demand in what they sell, their commodity, they also have not historically been playing in the thermal market other than piping gas. And so we're at the space of who wants to come in and claim that role as the entity that wants to build this infrastructure. And at the same time, while you build it, you have to also come up with the programs of how do you interact with it. We don't have a traditional model of sharing very well with utility, like on a thermal network. So are you paying for a BTU? Are you paying for resilience? How do we stack these things on top of each other? And then how do you guarantee that the waste heat from the data center, for instance, if that's the source, who are you paying them for their waste heat now?
Right.
Because they're going to promise reliability. Like, these are questions that the topic we've dealt with at the utility scale, but never at this weird intersection where it touches the building and is in a new form factor. So that's the part that's really exciting.
And I did hear you mention a few labs. So like Trina, I think you've talked about, how have you seen, the DOE labs and really that the IRA that we've kind of all been talking about play a role in really some of these projects that you guys are working with, and really all about around climate resiliency, which I know I threw that big question at the beginning, but like we all have a certain goal, right? But like it trickles down. So, what have you seen?
Yeah, and we'll get into it a lot because we have specific project examples. But I will say, especially someone, at my home base is really just a climate scientist working on all of this. Having the federal support to do this science and have that push there and have that be backed by millions and millions of dollars has made an insurmountable amount of change, both in what we see the national labs as collaborators doing, leading in terms of innovation, deploying it quickly, being a great partner, but just in terms of the project security that now clients feel like, why wouldn't I do a heat? This is what's being demonstrated on federal facilities. That leadership for us out of DOE, but also, just out of, the Biden administration period on climate change is something that should not be negated. Like, it should be celebrated a lot more. We keep saying, things have been changing so rapidly in 2 years. That IRA funding specifically is crazy.
Go ahead, Stet.
I was just going to say, one of the key things of it is that even the incentives built into IRA and the ICT aren't just electrical. And so the beauty is that they pulled in thermal storage is something that is incentivized at the level now that electrical battery storage is. And even though everyone talks about batteries, batteries have a very fixed performance criteria that they have to say, number of cycles that they can go through without degradation, peak amp draw. There's a lot of constraints around them. Thermal is super flexible. It's a big, dumb tank of water. Maybe if you want to be fancy, phase change material, but it has a lot more flexibility to meet the sort of time constraints, load constraints that a grid or a building campus might have at a given time. And so it's really exciting to see that incentivized at such a heavy amount, because the two things are interconnected. Whether you want it to be or not, there's an intersection between those things. And it's nice to see that huge push from the federal side.
And just to kind of like play, there's a lot of complex topics that we're throwing out at our listeners. And I also think, something that I've been trying to get real clean with my language is this idea that we all are a system. Our bodies are a system. We work within a system, and we're working and trying to change a system within systems. And this thought process that all of the answers are going to be known when you start on day 0. Seems to be like a common idea that the majority of humans believe to be true and do not realize the amount of effort it takes to actually learn some of these dynamic, difficult questions that need to be asked until you actually do. So when we think about the funding that was provided over a 2-year span and how much effort and organizations have went full force trying to figure out how all of these very complex systems could interact and work together, we've only learned. So like Aristotle said, we learn by doing. And so creating funding and creating a North Star or a vision, such as let's put a man on the moon, there was a significant amount of failures and losses and lessons learned that had to occur to make that feasible. But the one thing that remained true was the end goal. And so I think a lot of us that are on the outside looking in, thinking that a whole lot of things are not working or make no sense. But quite frankly, we're in the middle of it. There's a significant amount of championing and learning and successes. We just haven't figured out how to really get them out there and speak to them on higher levels because, again, it's so complex. So just like kudos to, those questions that you just said are very snarled or like gray are fundamentally you didn't know to ask them 2 or 3 years ago. And so now just that in itself is powerful. And that same thing is happening within the utility space is these devices or these technologies that when you do the penciling out and maybe may not make sense for where we are with the technology, but like what if? And that's the, hard part is staying focused on that what if and driving the cost curves to come down is like what happens, but there's a time. And we don't have a lot. Anyway.
People don't get excited about a lot of what you don't know that has come out of a lot of this funding is a number of pilots and pilot projects that aren't getting a ton of attention because it's small. It was like you think about IRA, all the investment that's coming in, billions, trillions of dollars. There's a lot of small pilots that have been testing some of these conditions to not only test the applicability of new technology, but also figure out if there are more questions worth asking. Like, and we don't celebrate that a lot. A lot of folks don't celebrate the journey. They're just like, well, what happened? I want to see like 4 bullet points. What happened? And you're like, oh, we opened up a door.
Right.
That's what happened.
That's my analogy I use with my children. You have to do the work for the doors to open, right? Now you're entering portals. So, there's pilot projects, and you mentioned projects, Katrina. What are some projects or examples you'd like to share? Or finish your thought that I just interrupted.
No, I was going to say it's generationally tricky too. Like I think the thing about these district systems, it's really exciting too about the thermal uses. It's the green job opportunity too, and that's something else that IRA, if you will, has done really a good job of doing. My dad for a long time, is like 4th generation steam fitter. Shout out to local 449. And I remember when I was telling him I was like super anti-fossil fuels and all of that a few years ago. And my dad was kind of like, well, that, put food on our table for years installing those pipelines, where would we be? And I was like, you could be just installing thermal pipelines. Like, would you rather work with gas or water? He was like, oh, water for sure. Right. So I think seeing the opportunity for really just clean energy, if you will, to be our man on the moon is something that I'm super proud of on our team. We come from different backgrounds, so our love language is really decarbonization, period. And having that as a man on the moon moment and saying like, hey, our job here is to make this project, to your point, just better for the next generation. How can we do that and not be scared of messing up is something that I'm really proud of our collaborators, a lot of them at universities. Because generationally, for 40, 50 years, people weren't building necessarily new technologies, right? We're kind of like, reinventing.
Incrementalism.
Yeah, it was like big centralized power plants and stuff. Like we were figuring out how to make nuclear work, which is super cool. But if you ask my grandpa, conversely, who was in the utility space, for him, he's like, oh yeah, you could try this. It might break, but you can do this. So I think it's an interesting thing that we're dealing with on our projects too, is there's a whole generation of leadership that gets a little bit nervous that it might mess up. And I think we need to make it okay for people who have a lot of responsibility on their shoulders to mess up when you're doing these things. It's okay. Like, let's fix it.
That's one of the other ways that the funding has actually helped is that a good chunk of the IRA funding is actually going to do these pilots on GSA facilities. So GSA is the landlord for all the federal, property, the largest landlord in the country. And they are taking some of this funding to actually do pilots on their own properties because they're taking that risk profile down. Like if you own a building and this is your first time doing it and you're like, I don't want to be the first one out of the gate trying this thing. Like we have to understand that the market has only a certain amount of risk tolerance because at the end of the day, it's their livelihood. It's, they might not have a huge, backlog of finance waiting there to help fix a problem. GSA can show the way by piloting these projects. Because it's GSA, the national labs can come in and have, instrument the projects to death so we can learn from the projects. So we learn why they're successful, but if they're not successful, we also learn.
Right.
And that is improving the market. That's improving the technology, because what we don't want as an industry is to go through CFL light bulb version 2.0, where we're like, hey, we got to do this thing. We're going to roll it out. And then we're going to have a bunch of unsatisfied folks in the field that are like, why do I look green? Why does this light bulb take so long to warm up? It was one of those things. But now as we look at the technology around heat pumps, district energy systems, to be honest, GSA and the federal government are doing a lot of the legwork to take the risk out for the larger population. And we're on those projects. It is incredible to watch. So shout out to GSA.
Yeah, double shout out to GSA because they just changed also as part of their decarb commitments. They've now required that their sites be certified for sustainability, which is kind of like the lead version of horizontal projects. And that's like quite novel for people. And actually, to your point on like systems and everything being connected, that's actually even helps the decarb discussion because in places where we're finding that water source heat pumps might be a solution, right? It's actually forcing also that another interdisciplinary, which has kind of been the missing in this, the world of civils, if you will, to kind of come together and say, wait a second, here's what's happening with water. Why don't you take that? And in so many places around the country, talking about it with flooding is turning into such a huge, glaring, obvious issue there's also now posing a threat for our utilities. It used to be just energy demand. Now it's, physical damage from water-based extreme events happening. It's been exciting to see the GSA come out and say, no, by the way, natural infrastructure is just as important as figuring out what your hard infrastructure is. So it just when you think like it's cool to just kind of be mechanical and electrical together, now we're like, oh, find your nearest civil buddy, partner up.
Turns out resilience matters regardless of where you're sitting.
So would you like to share some of the specific projects of success that you've had experience with? Or just to
we could
kind of concrete examples for those maybe planners that are sitting in the utilities wondering, is there a solution and or, those that are actively championing the technology that you're talking about, kind of have something to hang their hat on to think through for their next mission.
Well, you can definitely share. So we have two very large, like 1 million square foot plus renovations that are happening on the East Coast right now that are looking at all electric designs. And these are federal buildings and, very old, very complex, aged infrastructure, aged systems. One of the really cool things that we're getting to do is analyze even different types of heat pump technology, which are using different refrigerants, advanced all natural refrigerants, like ammonia, like CO2, which are turns out you can use as a refrigerant. You don't have to just release CO2 in the atmosphere. You can actually compress it and move energy with it, which is really fun. But those refrigerants often work very well in cold climates. And so pulling that thread all the way back to that efficiency story of how efficiency matters when we touch the grid, changing the refrigerant in your heat pump changes the efficiency of the heat pump and which climate zone it works best in. So CO2 loves cold climates. It can make very hot water in very cold climates. And so all of a sudden you might be able to cut in half the connected load on the grid for a heating system by changing a refrigerant out. That's a huge factor. If 40% of a building's peak load is associated with heating, and being able to cut that connected load in half, that's a really big deal. And so we have pilots that are just finishing design, so construction will be starting soon for that, and then a whole bunch of stuff on the district scale, which is really exciting. I don't know, Katrina, if you want to chime in on a project, but I can certainly share some of our university work as well.
Yeah, that's what I was thinking. I mean, University of Michigan is definitely one that we have to give a special shout out to. We've been working with them, as a team for 6 years, as a company for like 160 years, I think. But we started with the president's commitment to carbon neutrality and have literally worked our way all the way down to, carbon neutral renovation. And now we're going into actually, geothermal plant design to support, their decentralized energy networks, which has been super exciting. And chef's kiss cool to go back and use that phrase again. But that same type of, I like to call it like blue collar climate change, if you will, a little bit, because it's using those sort of strategies and applying them to smaller off branch campuses. University of Michigan Dearborn, University of Michigan Flint has been like really special to my heart, because I feel like we've really been super actionable about what to do. And, you know, it ended up working out so well. I think one of the projects that Stet and I are the proudest of is we did all of Indiana University, 7 different, campuses, which is 7 campuses, not even. And it's one of the dirtiest grids in the US. And, we figured out how to kind of take them to carbon neutrality, which was really exciting, figure out how to finance it and make it work. So it's the equivalent of taking 2 million passenger cars off the road for 1 year in total. So that was definitely interesting, but it's now pivoted us to, and I'll let Seth talk about it, because it's absolutely his baby. But on the West Coast, we're, doing an amazing project at UC Merced that is just been even cooler to work on.
Yeah, on that project, I think you have to it's not just about decarbonization. It's not just about the grid. It's also what is the community impact, the equity impact of making these decisions, whether it's on health outcomes in the community, whether it's at job skills training. So for UC Merced, we just delivered the equitable decarbonization plan for them, which is actually a mandate under the UC Office of the President for every campus to do this analysis. So the UC system is the largest system in the country, and each campus is doing this work. But there it was, how do we stay under our grid limit? Because, hey, we don't want to mess that up. What's the strategy for staying under the limitation? Because a new feeder for the campus is a 6-7 year planning process. So what are the strategies that we can do to stay under that limit while decarbonizing the campus, meeting our climate action goals, and also doing it as a way to turn the whole project into a living laboratory and a training program? So these are the sort of intersections that we get really excited about, because it's not just a technology. It's how do you talk about it? How do you bring the community together to see the benefits of it? That's how we make these transitions that are beyond just a pick the heat, because that's a boring decision.
Oh, we have to quick last one that we forgot. Check their website just as an example of where I think the coolest thing we're doing is also making this work fun, pretty, and beautiful. Like, special shout out to our graphics team, including Jenny. Like, oh my God, Jenny Hamel is doing an amazing job. We can't even. But University of Texas Arlington, super excited to be doing some Texas-based work where, not popular to say all the science things, but very popular to do.
Well, this is awesome. And I feel like, as I tie it together, because I think we could spend a lot longer discussing this.
We could do this all day.
And that is what's fun about, when you love what you do, is it truly a job? So I love meeting like-minded folks that really want to drive change and be the champions of change, especially bringing the awareness and the lessons learned from these new, and it's not really new, but ways to develop systems to offset this great energy demand that the industry is under right now. And so kind of thinking through, a lot of what we said is, what is happening with all of the technologies becoming available, and energy sources or how we use our energy is coming into question only for the sake of the many drivers, some much stronger than others. But it is taking the traditional one-way power flow that we've all studied and analyzed over the last 100 years to plan the grid, and starting to change that customer conversation and that awareness of how the customers can show up to ultimately and can be utilized as a benefit to the overall grid performance, as well as just support the other or defer to other areas to embrace, new other technologies. So it itself is a strategy that you don't know what you don't know until you hear and you listen, you lean in and you learn. And I think with everything that has become available, especially on this grid mod journey, is the data and the models and the analytics, which we will then be able to build trust back between the various stakeholders that maybe has been eroded over the last several decades, with the transparency and the data sharing that's going to become available. So I think you guys and the work that you're doing, the projects you're executing, was well worth the share to really tie in. The grid edge can really help offset this dynamic load demand, which we shouldn't really call our customers' request demands, but our load desire, our customer desire. data centers.
Wish.
And create the solutions in between. So thank you for your hard work and for showing up and sharing all that you guys know. I look forward to continue this conversation together.
Thanks, Elizabeth. It was great to be
Thanks for
here.
having us.
That's a wrap for this week's episode of the Grid Mod Pod. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.